Hello everyone, we are Counter Sugar. This name derives from the famous computer game Counter-Strike. We hope to have the courage of the Counter Sugar to battle against the most common and the most disastrous enemy in the household, the diabetes, which is T2DM, which is the most common type of diabetes. We want to find the antagonist of FXR to repress the blood sugar in patient's body. Now let's introduce Peter Liu to give us a first presentation about the background and purpose of our project.
Hello everyone, my name is Peter. Now let me introduce the background and reasons of our experiments.
Hello everyone, my name is Peter. First, I would like to tell you about the background. First, please allow me to introduce you the types of diabetes. There are mainly three types of diabetes: T1DM, T2DM, and gestational diabetes. T2DM, which also called type 2 diabetes, is the most common type of diabetes, and is caused by lack of insulin. We're working on patients' own biological function to solve the problem. Through document searching, we have found that one receptor called FXR is able to significantly repress gluconeogenesis. Research related to obese mice revealed that knocking off FXR is helpful in reducing the blood sugar. After several internal discussion, we finally settled our experimental procedure and plan is to find FXR antagonist, which can repress FXR and thus contributes to cure T2DM.
So after knowing what is our experiment purpose and background, let me introduce you our selected method in conducting this experiment and tell you what we have got as a result.
First and foremost, we have designed a find and confirm idea, which includes the finding of FXR antagonist in the molecular scale and the testing on the cellular scale. So let's go to the more detailed part. The first step to find the antagonist is to purify the FXR protein. We find that a part of sequencing FXR called FXR-LBD, which can bind to histidine, which can further attach to nickel column, and thus make it possible for us to purify the FXR protein. We can bind FXR to the nickel column and wash away everything else. Later, we can test the material have purified through SDS page technology. If the thing is really FXR, then the molecular mass will be comparable to the standardized example. Later, we will use a technology called alpha screen to screen the antagonist. The basic working method for alpha screen is like two magnetic balls that can emit light according to the distance between them. If the compound is antagonist, the balls will repel each other further and the light emitted will become dimmer. After selecting an antagonist, we further test its validity in the transactivation experiment. We select HEK293 cell, which is specially managed to replicate really fast. So we can use this to successfully employ plasmid transformation, plasmid amplification, plasmid extraction, and cell transfection to put thousands of FXR DNA into the cells. Later, we can employ the ferrofluoride luciferase to test the real effect of the antagonist. If the compound really works, then the level of action will be repressed. So the resulting light emitted by the ferrofluoride luciferase will decrease. Thus, we can find out what is really happening. So now let me introduce you the real result we have got from this process. After we successfully purify the FXR through the nickel column followed by ACTA FPLC according to the protocol, we used the SDS page to test the purity of 6-multiply histidine FXR-LBD protein. And as we shown in the figure 1, the 6-multiply histidine FXR-LBD was purified successfully. The second part of the experiment is to screen an effective FXR antagonist. During this part of the experiment, we screened the FXR antagonist in house compound library in lab by alpha screen technology-based assay. As indicated in the figure 2, among the compounds, H7 antagonized the GW4064 induced the promotion of FXR-LBD binding to its co-activator SRC1. Furthermore, H7 antagonized this effect in a concentration-dependent manner. The last part is about the transactivation experiment. The antagonistic effect of H7 on FXR was further verified by the transactivation experiment. As shown in Figure 3, FXR agonist GW4064 effectively activated reporter gene expression, and the H7 antagonized the GW4064 induced reporter gene stimulation in transactivation experiment. Thus, this result confirmed the antagonism of H7 against FXR transactivation activity. As H7 has been demonstrated a FXR antagonist, we will investigate the regulation of H7 against hepatic glucose reproduction and glucogenesis in vitro and in vivo in the future scientific research work. Here are our team's parts. Our core composite parts are BBA K3522001 and 013. The former one was used to express and purify FXR LBD protein and screen potential small molecular compounds in vitro. The last one is used to construct engineering mammalian cells to screen the compounds in vivo. In order to construct the composite parts, we designed several corresponding basic parts respectively, like promoters, terminators, tag, proteins, luciferases, and other necessary interval DNA.
To further explore the values of our experiments, we came up with the following modeling. Our primary objective is to forecast the changing trade of failure luciferase and the concentration of H7. Here is our data we used to develop the model. We averaged the fluorescence values of failure luciferase. Afterwards, we used the averaged values together with those of concentration of H7. We circled these two groups of data in red frame for your reference. Here we chose an explosion equation to make the forecast. With the help of curve fitting in MATLAB, we obtained the following results. The R-square here is 0.9411, indicating a good fitting effect. The biological guidance of this model could be that in the future, if some H7-related drugs are used to cure type 2 diabetes patients by achieving FXR inhibitory effect, a suggested appropriate amount of such drugs will be figured out by using the model.
So this is all about our experiment. While doing this experiment, there are a lot of chemicals that is harmful to our body, as well as some equipment. We need to make some safety plans. As well, we want to make some prospect with our results. So let's welcome Isaac to give us a presentation about the safety plan we have made and the prospect we want to achieve.
My name is Isaac, so how about the prospect and safety? Let me introduce it.
Well, we will start with cell experiments, animal experiments, human experiments, and then the clinical trials. As for the prospect, I think will be a milestone in medicine, because it has effectively changed the traditional course of treatment and cured diabetes. So I think such a technology will be supported and promoted. And with regard to drug safety, as I said, we will move forward gradually. So that's okay. And how about the safety? The air protection must be worn at all times. The short skirts, shorts, and open shoes must not be worn. The lab coats must not be worn outside laboratories and in public areas. Always wash your hands after handling chemicals and before eating. The food or drink is not allowed in laboratories where chemicals are used or stored. And also, cleaning work area with 70% ethanol after working. So that's all.
So while expecting the prospect, we also need to care about the current time. In a team of only 7 people, we really have done something that is great in human practice and fundraising. Now let me introduce you our lighting leader, Bruce Zhou, to give us a speech about what things we have achieved.
Hello everyone, my name is Bruce Zhou and I'm the writing leader of the Counter Sugar World Bank. So now let me talk about the activities we have done in the past few months.
The aim of our team is to develop a screening platform for FXR antagonists against the T2DM2. So how do we hold these activities? Firstly, we use questionnaire investigation. We do this not only for introducing our team to the society, but also for letting us know if people can understand the T2DM2 well or not. Thus, we can clearly know how to introduce our team to the society efficiently. The crowd showed encouragement towards our project and thus increased our confidence. Secondly, it's about publicity. We recorded and publicized the video to the Bilibili and TikTok app. At the same time, we also launched our public accounts on WeChat. Therefore, we can introduce our team to people about the pathology knowledge about diabetes and the project we are working on. We also held presentations about our program on and off campus, which allowed us to get some attention and feedback from the crowd. We also cooperate with East China Bilingual School, which hold a team called SNA. We paid attention to each other's public accounts and promoted peripheral products to each other. We have succeeded in expanding our influence to a wider area through such cooperation. At last, it's our peripheral products. In order to further promote our team project and obtain certain project funds, we designed our own team uniforms and sold it in Taobao online store, using 5,000 RMB donated by our team members. We have also designed many of our own cups and cabin bags, which are also available in our online stores. All these products have our team logo and name on it. During the sports meeting, we captured the hearts of thirsty athletes with our cups. At the charity sale, we let more people wear the team uniform of Counter Sugar to promote the fight against diabetes, which made many diabetes patients feel quite touched and warm. In supermarket and shopping malls, we carried our own designed cabin bags, which not only efficiently propagandized but also contributed to the environmental protection, causing a certain response among the citizens. In the end, not only did we earn back our money, but also get some unexpected extra income, which made us all very happy. Even after this competition, we are planning to further invest his project and make promotion. We want to show people who support us what we are doing and we really worth their trust.
I'm Zhou Pei, and now I will show you all the members in our team and I will introduce their attribution to you. The first man is our leader, Ethan Xing. In September, he conducted a survey on people's knowledge of diabetes to know that how many people clearly understand the cause of diabetes and how to treat diabetes. Of course, his main job is guiding other people's experimental operations and managing the team. When we are doing a group work, he will assign everyone's own work. The next people is our IT member, Zhou Pei, and it's me. In September, I established the WeChat official account every month. I edited 3 public tweets and published them. Meanwhile, I also do the internet work like uploading the videos about diabetes to the video platforms like Bilibili and TikTok. And also we have experimenters Liam Lu and Peter Liu. During the experiment, they had done a lot of experiments about the diabetes and FXR. After a day doing the experiments, they have to write the experimental reports in the night to record the medicine and the volume we used in the daytime. Also, they have to write about the result of the experiment. When we are doing the project, we also have a bunch of problems because we are unable to resolve them. So we decide to ask for experts' help. Therefore, we have the expert viewer Isaac Wu and the recorder Mike Kung. They are also an important part of our team. In October, we made a long line talks with the experts. The viewer Wu asked every question to the experts and the recorder Kung recorded all the answers from the expert. And the last is our dry team leader, Bruce Zhou. He designed our team logo and our team uniform, and also took the pictures and made the video about diabetes. There are other people also contribute to us and provide valuable advice to us. For this reason, we interviewed expert Wu and Shen, and we learned that it takes 10 to 50 years to develop a safe and reliable drug, which is a project with high input and low output. We need to know as much as we can about pharmacology, and we need to go through a lot of experiments before we can go from the laboratory to the clinic. In the terms of improving our experimental procedure, Dr. Wu proposed a multi-level analysis which was conducted gradually at the cellular and animal levels, which could speed up our experimental process to some extent. Previously, there were also drugs on the market for treating diabetes, such as metformin and plerixafor, but most drugs have side effects, such as nausea and diarrhea. Professor Shen points out FXR antagonists can improve sugar dissipation, which is another factor in diabetes, and this new in medical effect. Professor Shen think even though we may can't get a result, our research is able to open a new direction in making medicine and guide another researchers in the field. Finally, regarding the question whether FSR antagonists can be marketed, Dr. Shen points out that if FXR antagonist wants to be successful in marketing, they should strive to find a way to combine the drug with food, which is essential in Chinese medical market.